Thank you so much, Volker, first of all, for welcoming me this week at the Institute. It's really great, and also for inviting me to give this talk. I'm very, very excited to be presenting this paper. So before we go into the actual topic, I just want to say that besides the subject of the paper, there is AI liability that is very exciting right now. For me, this has been a very interesting project to work on because I've done it with two wonderful colleagues based in Hong Kong, Gleb Papishev from Lingnan University and Keith Chan from the Hong Kong University of Science and Technology, who are not lawyers. So I am the lawyer in the group. Gleb is an expert in policy and especially AI policy. And Keith is an economist that has worked on sustainability and smart cities, but also on AI. So it has been really a wonderful collaboration. This paper particularly is under peer review in design policy. It's been resubmitted to peer review, so we hope it will go well. We also have another paper that actually was the first product of our collaboration, to which I will refer because it's really about liability, the legal rules. So it's kind of the older sister of this one. And so, yes, great interdisciplinary work that I really appreciate it. So AI bonds, this market-based mechanism for AI liability. I'm going to start by just introducing the mechanism because when we have presented this paper before, if we go too much into the background right away, we don't give a view of what is our goal and what we are trying to achieve with this proposal. So I'm going to do that. So very high level kind of introduction of what we mean by AI risk bonds. And then I'm going to just try to be a little bit more detailed regarding the background and the legal background as well. So when we had this collaboration and we started talking about liability, we had the goal to kind of come up with some proposal, with some idea that could help us, on the one hand, not propose just more regulation of AI. That was not the goal. But also that could take into consideration what is really interesting and maybe a little bit special about AI, that, most of the things, the legal system has responses, but sometimes some really new questions come along. And I think some new questions come along really for liability when it comes to AI, because AI has some kind of unique behaviors, if I can use the kind of anthropomorphizing verb here or word. And so on the one hand, no more regulation, but some market-based mechanism that takes into account the specialty of AI and AI behavior when it comes to liability. And so the proposal of the paper is this, what we call AI risk bonds. So bonds, market-driven, and I have a very developed slide on how we price that. So I'm really looking forward to showing this work later. So market-driven mechanism, and we are taking inspiration from the catastrophe bonds that, is something that already exists, and I will refer to them later. And so the main, I think the main advantage, the main positive outcome of this type of mechanism would be that it aligns the financial incentives of AI developers and also of the public at large and the market with the commercialization of safer AI systems. And so a kind of nudge towards safer systems. And for doing that, it leverages the market and investor scrutiny and the transparency. So we try to do this. And so the basic mechanism, very, very bare-bone, is really the mechanism of a bond. So the issuer in the middle is the AI developer. We can also imagine different type of arrangements that could exist, but I think in the most basic form it would be that. And so it's a bond, and so the investors can decide whether they want to buy it and invest. And so they provide capital. The capital is held, maybe in escrow, but again, there could be other ways. But it is held until maturity, and there's, of course, a yield that is attached to it. And the trigger event would be, well, it has to be crafted in the bond, so it will be different every time, and we don't propose in the paper a list of triggers. But the idea would be that the AI bond is linked to a product. And so if that product causes harm, for example, chatbots that, I don't know, giving false information about some refundable tickets, which has happened already. And so if this adverse event occurs, well, then the principal is lost. Of course, there's no yield, so the investment is lost, but there is a fund that could potentially be used for compensating the victims. And again, the paper is very, very high level, very agnostic about this, because it depends on each legal system how you would actually operationalize this. I mean, it really depends how these type of claims are even structured. Just think about the difference between this type of claims in the US and in Europe or in China. It's completely different. But the idea would be that the developer would have available something that was preordained to be used for this type of event. But on the other hand, if nothing happens, then the principal is returned to the investors with the yield, and the yield actually would be commensurate. It's set in advance, but it's commensurate to the risk that the system is perceived to kind of pose over the time of the bond. And in the paper, we make this proposal that this should be 3 to 5 years, and this should cover medium risks, not extremely high risks, but medium risk that can actually happen and have happened already in when AI products or AI software in general is put on the market. So that is the basic idea, and I will try to say more about each part later. So for the methodology, we used a microeconomic model that we have borrowed, of course, from the existing models that, for example, from the catastrophic bonds. And so we simulate that the investor is risk averse, and there's an option to have a riskless investment, and then there's the bond. And so the idea is that if the risk that the AI system is perceived to pose, and so the probability of an adverse event is high, then of course the cost of raising capital for the AI developer is high as well, because of the yield that has to be attached to the bond. And so in a way, this could be a nudge to kind of invest into safer system in general, but also in disclosures and every possible way of explainability, even though we know how, it's a field that, let's say, it's developing at the moment, but in a way that the trigger on the bond can be worded, can be drafted in a way that the market perceives as safer. And so the adverse event is unlikely to happen. So this is very, very like an idea, a summary of what we try to propose. And so now a little bit of background. So how do we perceive, how do we define AI risk? So in the 2 rounds of peer review, this has been something that we have debated with the reviewers as well, and also when we have presented this paper in conferences. So what is AI risk? So I think, as I mentioned at the beginning, AI has some features that are different from the products that we usually find on the market. And so we try to focus, and we think that this instrument could be used and could be useful for these rogue behaviors of AI, and again, using the anthropomorphizing word for lack of a better wording at the moment. So we have heard and we have seen in research instances in which AI has displayed these behaviors that are inevitable, unpredictable, and intrinsic, meaning they cannot be fully eliminated in the current state of technological development. And so at the moment, no technique for enforcement learning or other type of method seems to be able to fully eliminate something like specification gaming, hallucination, goal-directed behavior that goes beyond what would be acceptable. And we cannot do that with acceptable trade-offs or acceptable costs. And so just to be really clear about this one, it is not, as the slide mentions, this is taken from the paper, it's about the limits of the present alignment techniques and not a claim of absolute inevitability. We're very happy if tomorrow everything is solved, there's no problem. But it doesn't seem to be what we're seeing. And one of the examples that we have kept in mind when we were working on this paper, but also on the other one, was the Anthropic paper that was published in June last year, where, of course, in lab conditions with a lab experiment, Claude was put into a situation in which it resorted to basically blackmailing. So maybe everybody is familiar with it. And so Claude was asked to reply to some emails and on behalf of a company, and then through reading all the emails that were given to it, it learns that is going to be shut down in a few days. And so tries different things. And of course, the researcher kind of cut all the corners for Claude. And the only available options seemed to be blackmailing the decision maker that, had some compromising information about him in the data. So, of course, again, lab experiment and, but for a lawyer, this is a very, very interesting, fascinating thing that you could have, a system that somehow, acts on behalf of a company that breaks the law and possibly a criminal offense and so on. So we had in mind this type of behavior. Of course, we have examples that are not so extremes. As mentioned before, we had chatbot hallucinating and creating economic harm for the companies that were deploying them. In other lab settings, we have heard of systems that were asked to optimize the traffic on a railway network, and the solution was stopping all the trains from running. So these are things that have happened in the last few years. Some of these problems might be actually overcome today, but the idea that we are taking from all this literature is that there is really a risk of these type of behaviors. And so until this is solved, the legal system and the market in general has to maybe kind of have some sort of solution for it. So this made us think of different things. One good, I think that we discussed more in the other paper, a good kind of analogy for this is what happens with vaccines and mass vaccination programs where you inject a drug to people who are well, and some of them, very few of them, might develop some even very, very serious side effects. And so we were thinking about natural disasters, though it's a less good of analogy. But anyway, so we were trying to think of this type of examples and how for natural disasters, for mass vaccination programs, we have come up with some innovative solutions, and we maybe need the same thing for the harms that might be caused by AI risk. So, the current systems, the current framework for liability and insurance, we think is not fully prepared for all of this. in a nutshell, for liability, the rules on liability are basically as old as the world. And of course, they function very well based on the assumptions that have always functioned, causality and control in particular. And so I have slides for each type of liability. Maybe I will go a little bit faster through them. But so the idea is that all existing rules on liability are not fully prepared for the complexities of AI because they rely on notions that AI with this kind of behavior tries to challenge. So in the legal literature, authors have looked at fault liability, strict liability, and product liability to see which system would be better for AI. And our claim is that, based also on this extensive literature, that none of them is really fully adapted. For fault-based liability, the problem is that there are a few problems on the slides, but to kind of make it a little bit more succinct, you need to kind of prove that someone breached a duty of care. So some sort of conduct standard that is set for humans, and that is very hard to do for AI because of the black box problem and other things. So fault liability seems to not be so adapted. It is true that we as a group, but also other researchers, are trying to see if actually fault liability is not in the end the best option that we might have, with some tweaks and with some adaptations. But at the moment, the rules that we have are not fully functional for AI. The same thing for strict liability, and this is maybe for the lawyers, one of the most unpopular claims of our paper is that strict liability is also quite not adapted to AI. So strict liability is when someone is held responsible for something that happened because they had a certain role. So the employer for the employee, the pet owner for the pet, parents for children sometimes. So this type of examples. And a lot of authors have seen in this as the best possible option for AI because it appears to be a very risky technology that we don't understand very well. And so it kind of, it seems quite natural to put on the companies that develop the systems and put them on the market and benefit greatly from them. The responsibility of paying is if something goes wrong. But there is also literature that has pointed out that this is basically unfair and wrong. And it just, displaces liability to a place where, you might find deep pockets, or you might, kind of find someone at the end of the chain that could be held responsible easily, in the sense of legally, it's very easy to think about, but maybe these companies don't have actual control, especially on those behaviors that we were talking about before, because they tend and they might develop after the product is on the market because of learning and interaction with environments and with data. So we think that it's really not very optimal to think in terms of strict liability. And then the third option is product liability, and we have, historically, the European Union uses this method. So it's halfway, if we can say, between fault and strict liability. So you need a defect. You need to prove the existence of a defect in a product that leaves the factory. And then if you can prove that, then and you can prove the causality between the defect and the harm, then the developer or the manufacturer can be held liable. But again, a lot of authors have pointed out that this is kind of maladapted to AI, because what is a defect in a system that might kind of evolve as it interacts, as you use it, basically, as it interacts with the user and with the environment. All those emergent behaviors and this kind of learned new things that happen with AI, they're probably not defects, but maybe they also turn the product unsafe to an extent. So it is a gray zone, and it might be adapted. We think that it can be adapted to AI, but as it is, including the new Product Liability Directive, is probably not yet fully ready for AI. So because of this discussion that we kind of developed more in the other paper as well, we think that we need new ideas, and we need also to kind of find ways not to rely on, things like, for example, strict liability for developers, thinking that in the end they will take out insurance and that, it will be fine in the end, the kind of this kind of approach. Also because insurance, there's, again, a lot of work that is being done about how the insurance market could be kind of adapting to AI. Traditionally, insurance companies are the risk absorbers, and in the past, maybe 30, 40 years, maybe even a bit earlier, claims for product liability have been rising in the US, for example, but in many different jurisdictions, there's plaintiff-friendly legislation. There are contingency fees for the lawyers, and so for as much as we like the idea, and I like the idea that victims should be compensated when something bad happens, it is also true that it is a field where the cost of insurance has been rising before AI, and with no link to AI. And it is true also that, on the other hand, very few risks are uninsurable. I think we all been learning about this. In case of war, some insurance policies stop covering those kind of harms. But even if a risk is not fully uninsurable, and again, it's very rare, it can actually become so costly, so expensive, that only very few players in the market can afford it. And so the literature has been talking about subjective uninsurability. So for some people, based on the market profile and the risk concentration in the market, might not be able to insure some risks. And so there are responses to that. So the first one that one may think is a government-based kind of system. And we have it actually for things like vaccines, adverse effects, and other type of harms. But of course, there's a trade-off here, and because you're socializing this risk, to what extent it becomes sustainable and also fiscally sustainable. So our proposal really kind of is in this particular part of the market and the issue that, you might have something that complements not so much a public system of insurance, but it complements the private insurance that becomes too expensive for certain players, or just might complement it for anyone. And the interesting part of a bond is that it kind of works because the market prices it, even if it's an unknown. That we most of the AI risk that we talk about is probably still unknown. It might become known unknown, but at the moment, we still cannot really put probability on it. So how do we structure and how do we price the bond? So basically, we are adapting. I'm not sure if I'm pointing to the right things. So, but we are adapting a model from other type of bonds, so the catastrophe bond that I mentioned before. And because I'm the lawyer here, I also want to point out for the lawyers that though this looks very maybe too much mathematical for lawyers. Actually, it puts on the lawyers, on the people who have to draft the trigger event, a lot of pressure, because if the trigger event is worded correctly, then the market will be able to price it correctly with the risk. So as I mentioned before, we have here. We have this representative investor that chooses whether to go for the riskless or for the AI bond, and we set it as risk averse. And then here we so basically the bond's fate and what happens to the bond is determined by Z. And so if the realized impact is negative, so there's a harm, and in that case the bond is default. And if it's benefits, then the opposite. So one thing that we got pushback from peer reviewers here was that, if an AI developer makes the system and cannot really estimate how risky the system is, then how can anyone, this investor, how can anyone actually be sure of what kind of risk we are talking about? But I think here there's a subjective distribution, or it's a subjective kind of perception from the investor, and which is what actually is relevant for the pricing. And then we can also maybe talk a little bit more about that later. And then for doctrinal part of the instrument, as we put it, that is where the lawyers need to kind of write the trigger very well. So if the contractually defined threshold is realized, then the investors lose the entire principal. If it's not, then they receive the capital back and some yield. So on the left, participation condition for the market. And so if the expected utility matches the riskless possible alternative, then the bond, the market will absorb this bond. And on the other hand, sorry. And here, and here, on the other hand, is the risk premium. So the price that the issuer pays for transferring the risk to the investor and to the market. And so from the model that also we have full draft in the paper, so I'm happy to share. There are two kind of main takeaways that we take. One is that the AI developer that invests more in safety and also in kind of explaining that safety to the investor will lower the cost of capital, and also the investor that will actually take what already exists in the law that are transparency requirements really seriously, might also lower the cost of capital, because more transparency will actually allow the investors to see, to better appreciate the risk. So I don't know how much time I have left, but we just want to also, because we got some comments from peer reviewers on this one, what are the kind of the important things that really need to be the pillars of the structure of this bond that really need to exist? Because again, the paper is very general about how this should be implemented, because it really depends on the legal system where it's set and on the applicable law. But there are a few things that really need to be there. And one important point that was really discussed in our peer review is the existence of third-party auditors. And here again, one of the issues would be if the AI developer that puts the product on the market is not in a position to really assess the risk, why would anyone else, including an auditor, be able to do it, and how would that work? So we think that supply and demand, and it's already happening, third-party auditors that audit AI systems and all their features, including how dangerous they might be or what could happen, are really developing. It really exists already. Protocols are being developed. Again, it's an evolving market. We can say a lot of things about it, but it's happening, and sometimes it's even illegally required. So I think that relying on third-party auditors is not something that is unheard of in this field. And just something else that I wanted to mention about this, I think is in the other slide, in this one, is that yes, we have kind of feedback from other markets where audits and rating agencies have not been let's say, doing their job all the time and always in an impeccable way. We have in the paper a few, I don't know where my hand is, a few propositions about, a few proposals about how this could actually work a little bit better with, rotational assignments and kind of conflict of interest rules that could be put in place. And also the fact that auditors are just one part of all of this, and there's also the other layer of the market that appreciates not just what the auditors have said, but the whole kind of drafting of the trigger. And we also think that there's a sort of feedback loop that can emerge from all of this, because if you start, drafting your bonds not correctly, then, the market eventually will stop believing in them. So kind of sort of self-correcting mechanism as well. So I think I mentioned everything, including the notes that I was given from my other co-authors. I have a slide that kind of tries to summarize all of this so the idea that because liability fails or is still not optimal, I would say, then we propose something that can kind of reframe the problem, though we know that this particular proposal doesn't solve the issues that I mentioned of the rules of liability, just kind of adds to them and creates a new thing that can help manage the risk. And so it's a kind of a complement, not a replacement. And we also have this one showing how, what we mentioned could be the very features of AI that make liability rules difficult to apply and insurance costs also escalate, like opacity, autonomy, and generally speaking, emergent behavior, again, with some allowance regarding the language of it here, how the different variables of the model can actually address all of these issues in a way that possibly makes it more priceable. Yeah.